This class is Math with Joy. So today we're going to be looking at differential calculus, and I want to believe that you've seen our video on differentiation by first principle. Now, by the end of this video, you should be able to differentiate basic algebraic expressions without using the first principle. Now, before you ask, what's the relevance of differential calculus? I hope you know that differentiation helps you to find, for instance, speed of a moving object, the slope of a curve, even maximum profit of a business. So in this video, we're going to be seeing how. So if you've not subscribed to this channel to get notification on our videos, please do so. Also like, share, and comment. So in our last video, we concluded that for any function y equals x raised to power n, that the derivative of x raised to power n with respect to x is equal to n x n minus 1. So now that means, on a general note, if I have y to be equal to 3a raised to the power of n, let's say plus b, and then I am to differentiate this y with respect to a. Now, if I'm to differentiate this function with respect to a, what happens? Get used to this rule. Bring down, multiply, reduce the power. Now, since I am differentiating with respect to a, and I don't have a in the second term, so this becomes a constant. So when you differentiate a constant, you have 0. Okay. So now look at the three things I mentioned. I said bring down. So that's the hack. Multiply, reduce the power. Did you see it? So whenever you are to differentiate an algebraic expression, just take it like that. Bring down, just like we brought down n. Multiply. So multiplying, we will have 3a raised to the power of what? N minus 1. So we have bring down, which we have done. So the next thing says multiply. So if you multiply, we'll have 3n a. Then reducing the power, we have n minus 1 plus 0. So that's our what? Derivative of the function x. Okay, so now the next thing that comes to your mind is that, what are the rules of differentiation? Now, we'll talk about these rules. We're going to be focusing on explicit functions first. So, rules of differentiation. Now, for the person asking which one is explicit function, don't worry, you'll get to know differentiation. Okay, so the first rule, we have the derivative of sum. Derivative of sum. So now if f of x is equal to the function of x, u, which is a function of x, plus v, which is also a function of x. Okay, so that means we have three functions here. All right, so f, u, and v are all functions of x. Then dy dx is equal to differentiate the function u with respect to x plus differentiating the function v with respect to x. Now, in this sum, you can actually have more than two functions. All right. So differentiating derivative of sum is a very simple. Is just so derivative of sum is basically summing all the what derivatives. Okay. And u is also what, a function of x. So that dy dx, that is when y is a function of, did you see the function of function now? Okay, so my that dy dx will be equal to dy du, which is equal times what? Du dx. So you see that when this cancels this, you have your dy dx. So example of functions like this, you know that if I have x plus 2 squared and I'm to differentiate, I can actually expand this. So when I expand, I have an algebraic expression, then I can actually use derivative of sum to do it, right? Okay. So now what happens if I have x plus 2 raised to the power of, let's say, 4 over 5? You see, I can't do it that way, right? So that is why I have to bring in the chain rule. Okay. So that chain rule is saying assign a variable to x plus, so y is equal to u raised to the power of 4 over 5, where u is equal to x plus 2. Are you seeing it now? So that is function of a function. Okay, so now let's look at all the rules, then we look at examples. Okay, so the next one will be product rule. The product rule. So now this product rule is saying that if the function y is equal to uv, where u and v are functions of x, that dy dx is going to be equal to v du plus u dv. Of course, it's with respect to x. Okay, so you know that addition is commutative. So whether I say v du plus u dv or I say u dv first plus v du, it doesn't change anything. The only thing you need to note is that it is the function multiplying the derivative of the other function. Okay, so whether you do this first or you do this first, it is still the same. Just add. The only thing you will note is that you don't multiply v with its derivative. It is a no. Are you getting me? Okay, now please note that all these formulas were derived from the first principle. So I don't want to bore you with all those theories. Okay, so now example of this product rule is if I have, let's say I have x minus 1 and then I have x plus 2. I have two factors. Okay, so this is my u, this is my v. All right, so this is pure example of a product rule. Then the last is the quotient rule. This will be wrong. Okay, so it is v du first. If it were to be addition, whether you do it as that's for product rule, whether you do it as v du before u dv, whichever way you do it, you will still be right. But for quotient rule, it is v du minus what? U dv. So now, before we look at examples, I want you to note that in solving a problem, you can actually apply more than one rule. So let's look at these examples together. Okay, so we are to find the hmm? So we are to find the derivative of the following functions. Okay, so now if I write a question, you tell me which of the rules you think will go and why. So we have y is equal to 4x cubed plus 2x raised to the power of what? 1 over 2. So what do you think? Do you think this is derivative of sum because I have addition? And then looking at it again, there is a power because every expression is in a bracket and there's a power of half. Okay, so what comes to your mind? The chain rule. Exactly what also came to my mind. So now I will say let u be equal to 4x cubed plus 2x. Okay, now before we continue, Subtracting 1 from this power, we have 0. And x raised to the power of 0 is 1. Okay, now chain rule says that the y dx is equal to the y dx, the y du times du dx. So what's my dy du? My dy du is half u raised to the power of this. Okay, so I'm applying the law of indices here. I want to write it without having the negative index. So I will have 1 over 2u raised to the power of half times 12x squared plus 2. Okay, so before I substitute my u, let me simplify the expression first. So from the numerator, I'm seeing something common, which is 2. So if I factor out 2 from the numerator, we would have 6x squared plus 1 all over u raised to the power of half. So what's our u? Our u is 4x cubed plus 2x. Okay, so when we substitute that, we will have our dy dx to be equal to 6x squared plus 1 all over 6x cubed plus 2x. So we can simplify further. Okay, so that's our answer. If we can simplify further, we go ahead and simplify. We leave our answer to the simplest form the expression can take. Now, moving on to the second question. To the second question, we have y to be equal to 1 plus x times x minus 2 raised to the power of 3 over 2. Okay, now before we continue, there was something I was saying about those who will be answering this in JAMB. Now, you see these shortcuts. Some people will tell you that if you have to avoid let me show you here. Some people will tell you that if you have y is equal to x plus 3 raised to the power of half, now you shouldn't stress yourself, chain rule, whatever. You should just bring down the half, right? Do it like normal differentiation. Okay, then if you subtract 1 from half, you have minus half, abi ahead. Then if you now choose to rewrite, that you will have 1 over 2 into x plus 3 raised to the power of half, right? Thank you. So now, and this is my response to this. This is very okay. Okay, very, very okay. That's for OBJ. For objective question is very okay. But take note of one thing. Take note of the expression inside the bracket. This is a simple linear expression inside the bracket. And if you differentiate x, you get 1. So this will only work when the derivative of x is 1. If the derivative of x is not 1, that means you need to know how to. Are you getting what I'm saying now? Exactly. So shortcut, shortcut, shortcut. They will show you where the derivative of x is 1. So if you differentiate x and it is 1, you know that anything you multiply by 1 is still that thing, and that's why this will work. So what happens if you now have, let's say, 3x squared plus maybe another 3x raised to the power of 5 or something? What happens in that case? Do you now know how to do the shortcut? So that's why I said I'm going to show you something. Okay, now moving on to the next question. If you look at this, I'm saying product rule, but then I have 3 raised to the power of 2. Remember, before we started these examples, I said we can actually apply 2 rules in solving one question, right? Okay, so if my u is equal to 1 plus x, and then my v is equal to x minus 2 raised to the power of 3 over 2. Okay, so now since this is a product rule, y is equal to uv, how do we differentiate using product rule? That's the y dx is equal to v du plus u dv. So now finding our du, differentiating it with respect to x, we have 1. You see? So in this kind of linear expressions in the bracket, it's very easy to apply shortcut. So now coming to the v, this is chain rule, function of function, x minus 2 all raised to the power of 3 over 2. So since the derivative of x will give me 1, I can then say that my dv will be 3 over 2 into x minus 2. So 3 over 2 minus 1 will give me half, right? Because half plus 1 is 3 over 2. Okay, so this will work here. Why? Remember what I said. And now, but you said that in theory it doesn't work. Why are you now doing it? Well, the function given to me is not just chain rule. It's product rule, but then there's chain rule in the product rule. Are you getting me now? Exactly. So that's why I can do it and get away with it, because all I need is to find my dv, then continue with my product rule. Good. Now I have my dv to be this, then I have my dy dx to be equal to v du plus u dv. So what's my v? My v is x minus 2 raised to the power of 3 over 2 times what's my du? My du is 1. Okay, plus what's my u? My u is 1 minus 1 plus x. What's my dv? My dv is 3 over 2 into x minus 2 raised to the power of half. Okay, so now can I simplify this expression further? Looking at this, there are no like terms to collect, so we'll have x minus 2 raised to the power of 3 over 2 plus 3 over 2 into 1 plus x minus 2 raised to the power of half. As simple as that. You leave your answer this way. Since the power is fraction, you cannot open the bracket, so we leave it that way. Okay, and there are no like terms to bring together. So now the last but not the least, we raised to the power of half. So now differentiating u with respect to x. So in your shortcut, you remember that know when the coefficient of the variable is positive and negative. You know, if you differentiate x here now, you have minus 1. So that means I will have minus half into 2 minus x raised to the power of minus half. And then if I differentiate v with respect to x, I will have half 2 plus x raised to the power of half. Okay, so my v du, let's deal with the numerator first, minus u dv. What's my v? My v is 2 plus x raised to the power of half. While my du is minus half raised to the power of 2 minus x raised to the power of minus half. Minus, what's my u? My u is 2 minus x raised to the power of half times, what's my dv? My dv is half 2 plus x raised to the power of half. Here, remember we factored out minus half. So if we take LCM of what we have inside the bracket, we will have 2 minus x raised to the power of half. We're still working on the numerator so that when we are done, we bring in the denominator. So we'll have 2 plus x times half of raised to the power of half times 2 plus x raised to the power of half plus 2 minus x raised to the power of half 2 minus x raised to the power of half. So this is where we can bring in the law of indices, where we add the powers, okay, given that the bases are the same. So half plus half is 1. So we have 2 plus x plus 2 minus x all over, remember we have our minus half. So this is all over 2 minus x raised to the power of half 2 plus x raised to the power of half. So let me bring in my half before I forget it, my minus half. Okay, now simplifying in the numerator, this will go. So we have 4 over 2 minus x raised to the power of half times 2 plus x raised to the power of half. So now remember that this is multiplied by minus half. Okay, so 2 divided here will give you 2. And minus 1 times 2. So for the numerator, we have simplified it to minus 2 all over 2 minus x raised to the power of half times 2 plus x raised to the power of half. So bringing in the denominator over v squared, and our v squared is 2 plus x raised to the power of half. So squaring, according to the law of indices, this will cancel out. So we have 2 plus x minus 2 all over 2 minus x raised to the power of half 2 plus x raised to the power of half times 2 plus x raised to the power of 1. So now if we add the powers of this, half plus 1 will give us 3 over 2. So our final answer, dy dx, is minus 2 all over 2 minus x raised to the power of half times 2 plus x raised to the power of 3 over 2. So I want to believe that you enjoyed this video. Please do not stop at these examples here. Look for more questions. Like I said earlier, these algebraic expressions we just differentiated are simply explicit functions. So in our next video, we're going to be looking at how to differentiate implicit functions as well as application of differentiation. See you in our next class. Do have a lovely day. Bye.